5.5 Change of basis analysis. Starting with two-sphere example, let's consider a change of basis. E sub alpha equals E sub beta A sub alpha to the beta dash. This results in a gauge transformation to get the new connections, non-tensorial, and have equation 5-99. Equation 5-100. Consider a two-sphere, equation 5-101. Equation 5-102. Equation 5-103.
So, can now compute 2r, in coordinate frame equation 5-104. Equation 5-105. Using the Landau expression, equation 5-106. Equation 5-107.
Rather than the coordinate basis, E sub theta equals partial differential sub theta comma E sub phi equals partial differential sub phi, let's transform to a Lorentzian basis. See the equation. So, see the group of equations.
Note that this result is not symmetric due to incompatibility of connection with metric. So, putting this together, equation 5-108. For the right group we simply have negative r to the negative 2 times 2 cotangent squared theta. For the left grouping we have equation 5-109. Thus, see the next equation shown.
5.6 Change of basis analysis. For Landau form, we want to take the Landau form r equals g plus the fraction with numerator 1 and denominator the square root of g times the square root of gw to the script l subscript comma script l over to a new basis. But this is non-trivial because w to the script l is not a true tensor. This requires a review of the Landau derivation. Starting with equation 5-110. And the gauge relation. Equation 5-111. Also recall in coordinate frame.
Equation 5-112. And from the alpha beta power of g semicolon gamma equals 0, equation 5-113. Then equation 5-114. The new basis is not a coordinate frame, so modifications are needed. See the equations.
Similarly for C the equation. Thus see the group of equations shown. And using C the next equation shown. Thus see the group of equations.
When a sub mu to the mu equals delta sub mu to the mu and normal gamma sub gamma delta to the delta equals the fraction with numerator 1 and denominator the square root of negative g times the square root of negative g sub comma gamma for coordinate frame, the familiar equation results, so see the equations. Returning to the 2r calculation as a check, see the group of equations shown.
5.7 The spatial ADM metric evaluated in coordinate frame and orthonormal frame. The spatial metric d script l squared equals l squared d r squared plus r squared d normal omega squared has been examined in the coordinate frame. See the equation. The connection coefficients are. See the group of equations.
And the normal gamma sub jk to the is are symmetric on the jk to the prime s since this is a coord frame with metric compatible with connection. Now to switch to the orthonormal frame, see the next equation shown. And E sub alpha E sub beta 8a to the alpha beta equals 1 where 8a sub alpha beta equals dr times dr plus r squared d theta times d theta plus r squared the sine squared of theta d phi times d phi.
So, for E sub alpha equals E sub beta A sub alpha to the beta, and defining a sub alpha to the beta dash. See the equation.
Then see the equations. Here are the gammas. See the group of equations shown.
From the calculation previously, see the next equation shown, where see the equation, and where all explicit derivatives are coordinate derivatives. See the group of equations.
Thus see the equations. Thus see the group of equations shown.
Thus see the next equation shown. Let's now consider a change of basis from spherical coordinate frame E sub alpha equals E sub r comma E sub theta comma E sub phi to Cartesian coordinate frame E sub beta equals E sub x comma E sub y comma E sub z and E sub alpha equals a sub alpha to the beta E sub beta, and where d script l squared equals l squared d r squared plus r squared d normal omega squared equals g sub mu nu of dx to the mu dx to the nu, with dx to the first equals dx comma dx squared equals dy. Comma dx cubed equals dz. We can determine a sub-alpha to the beta from coordinate relations.
See the group of equations. Thus, see the equations.
Shifting to a matrix representation. See the equation.
And see the next equation shown.
Thus see the group of equations shown.
And the determinant is evaluated as follows. See the group of equations.
In MTW notation, equation 5-115